Okay, let's take a look at section 6.5. In 6.5, we introduce a bunch of properties of logarithms that are basically just algebraic properties of logarithms. Earlier in this chapter, I made a video where I went over a bunch of properties of exponents, right? Things like how when you multiply two exponential things with the same base, you can just add the powers together. Stuff like a power of a power can be simplified by multiplying the powers together. All that stuff, right? And those properties all translate, well, not all of them, but many of them will translate like nicely into log properties that are kind of the equivalent properties for logarithms. So this video, I'm going to go over a few of those, a few key ones, and show you how to use them. But before we get to all that, I want to write down what I think is the most important properties to remember about logarithms, which are the inverse properties. Okay. And that means that since logarithms and exponential functions are inverses of each other, if you compose them together, then they cancel each other out. Remember that f of f inverse of x equals x, right? If you compose two functions that are inverses, they cancel each other out and give you back whatever you stuck in there, right? As if you hadn't done anything. This is the identity function. So that means that if you do log base b of b to the x, okay, where you're composing a log base b and an exponential base b, as long as the bases are matching each other, then they cancel out perfectly and give you back whatever you put in. Okay? And then the other one is if you take the b to the power x, but then you compose it with log base b, so you stick a log base b inside of your exponential base b, all right? Then they also cancel each other out and give you back x. So that it only works if the bases are matching, because every exponential function has a specific inverse, which is a log function of the same base, all right? So the bases have to match. If the bases don't match, there are other properties we'll learn to help you make them match, potentially. So hang tight, and we'll get to that soon enough. So now let's sort of review some of those properties of exponents, and then we're going to introduce the equivalent property for logarithms. So the first one I want to go over is if you have b to the power m plus n. Right? If you've got a base b and then you have two terms, m plus n, you may remember that this can be split up into b to the m times b to the n. Okay, you may be more familiar with this property written backwards, where you start with the multiplying of two exponential expressions and then you combine them. But it's perfectly valid to write it this direction as well. So the way I want you to see this is, on the left side we have a single exponential function with addition on the inside. And then it's equivalent to write that as two exponential functions combined with multiplication on the outside. Okay, let me say that again. For exponential functions, addition on the inside is equivalent to multiplication on the outside. This is called the product rule. Okay. And there's a product rule for logarithms, except it swaps. Since it's an inverse of an exponential, the inputs and outputs, insides and outsides, are going to swap around. So instead of having addition on the inside and multiplication on the outside, swap it. Log base b of m times n, okay, so now we have multiplication on the inside is equivalent to log base b of m plus log base b of n. Addition on the outside. Okay, do you see how that swapped around? Addition is on the inside for exponential functions, but multiplication is on the inside for the log function. Multiplication is on the outside for exponential functions, but addition is on the outside for log functions. So there's a number of different ways you can say that. You can rearrange that sentence in a bunch of different ways, but as long as you see the inside-outside swapping, I hope that you're getting the idea. So now you can probably figure out what the equivalent property is for this one. The exponential property is b to the m minus n is b to the m divided by b to the n. So subtraction on the inside is equivalent to division on the outside. This is called the quotient rule for exponents. And the equivalent quotient rule for logarithms, see if you can figure it out. We're going to swap it around. Here it is. It's log base b of m divided by n equals log base b of the numerator m minus log base b of the denominator n. So division by n on the inside is the same as subtracting the log of n on the outside. Okay, so basically whereas these properties are sort of, we often use these to combine things together. Logs here, we'll often use them to pull things apart. Although you can do the opposites as well. You can use these to pull apart, or you can use these to combine together. There we go. So there's one more of these. The property from exponents says b to the m times n is take your b to the m that you had and then raise it to the power n. So this is on the inside of the function. We have multiplying the input by n right here. Whereas on the outside of the function, it's like taking the entire output and raising it to a power. So multiplication on the inside is a power on the outside. This is called the power rule. And then the equivalent property for logarithms says if you have a power on the inside, so that is m to a power n, these could be any two numbers really, but m to the power n, if it's a power on the inside, we can rewrite that as multiplication on the outside. There we go. All right, so those are the main three properties. These are by no means the only properties of logarithms, but these are the main ones we're going to work with. So now let's try doing some things. Let's try doing some math with these properties. So one thing you can do is you can condense. Condensing log expressions. Oops. If you have something like 4 times 3, I'm going to use common log here, but it works with any log, okay? 3 log of x plus 5, plus log of x plus 5, and then minus log of 2x plus 3. If you have something like that, we can take this and combine all these things together, because you'll see all of these are logs, right? So they're all log base 10. All the logs, log bases are matching, so we're going to be able to use these properties and smush everything together. The goal here will be to combine this all into one logarithm. But before we do that, we have addition and subtraction. So those, when we combine, are going to become, addition will become multiplication and subtraction will become division. But before we do that, we have to take this power and stick it back inside there, okay? And I know there's a multiple on the outside, but we're going to get to that later. Okay, we're going to get that multiple of 4 we'll get to later. So let's take that multiplication by 3. And we're going to use the power rule to say multiplication on the outside can go inside the function and become a power. So this is going to be log of x cubed plus log of x plus 5, and then minus log of 2x plus 3. So now we're going to take all these things and combine them together. 4 times a single logarithm. And the single logarithm is going to have a product. We're going to have x cubed times x plus 5. So x cubed times x plus 5. Because addition on the outside here, the addition of these two logs will combine into a single log with multiplication on the inside. And then if we're subtracting log of 2x plus 3, then we're going to take that whole thing and divide by 2x plus 3 on the inside. So all these 3 logarithms here combine into one log, with addition becoming multiplication, right there, and then subtraction becoming the division. Now this whole thing is to the power 4, so we can finish this off by doing log of the x cubed times x plus 5 all over 2x plus 3. And then since it was multiplying by 4 on the outside, if we bring that in, I'll use my purple marker again. I'm going to bring that in and turn it into a power. I have to take, oopsie daisy, this parenthesis should be here. Not there, my bad. I have to take this entire expression, which is inside my logarithm, and raise it to the power 4, like that. And that's how you do this compressing or condensing of log expressions. How am I doing? 9 minutes. Let's do another 1 or 2 of these things. So that's condensing. Now let's try expanding. Expanding logarithms. So now we're going to use the properties in the other direction. Let's start with the natural log this time. And let's take x squared times e to the x, and then all of that to the power x. Okay, this is the type of thing that you might end up doing in a calculus class. My calculus students, I teach them how to use log properties to make some calculus problems easier. And people rarely remember all these log properties, so I have to go over these again. But let me show you. So I'm going to show you the type of thing that you would do in calculus. So this is an expression. What we have inside here is an expression where the base is an exponential expression where the base is a function of x, and the power is also a function of x. It's a super weird type of expression that doesn't come up very often, but it's kind of interesting. And so here, if you do a logarithm of that, we can use the log properties to break this up into separate pieces. So the first thing I'm going to use is, getting out the purple marker again, I'm going to use that power rule, which is going to take this power of x on the inside. This whole thing is to the power x. I'm going to pull it out and make it a multiple on the outside. And now what's left inside my logarithm is just the original base, x squared times e to the x. I'll put a dot there for times. So there's the multiplying by x is now on the outside of the log. So next, I'm still going to have that x times. Next, I'm going to take this logarithm of a product. Since this is a product inside here, right here, we can break it up and turn that product into a sum of logarithms. So I'm going to need to introduce some parentheses for my sum of logarithms. Now we're going to have the log of x squared, and then plus the log of e to the x. Okay, so I'm separating this into two logs, one for each of the factors, and then I'm adding those together. That's the product rule. So next, we can do a few more things. This power can come outside, just like the other power did. Okay, this is x times 2 natural log of x. And then over here, we can actually apply the inverse property. This is natural log of e to the x. Those are going to cancel each other out. F composed with f inverse, right? That's what's going on there. So the x itself is going to be all that's left over after those functions cancel. And there we go. There we go. We split it up and pulled it apart, and we got this, which is way simpler than what we started with. X times 2 log of x plus x. Or if you'd like, 2x log x plus x squared if you want to distribute that multiplication by x. So whichever of those you'd like better or think is a little bit simpler to work with is the one you could use. So this is using log properties to combine and expand. All right. Now I want to point out something really important here. If you have something like log base 2 of x squared plus y squared, okay, if you have something like this, you cannot split this up. Probably the most common mistake with using logarithms is like forgetting that what you can do is split up a log of a product into a sum of logs. But if you have a log of a sum, if the addition is on the inside, there really isn't anything you can do about that. Like, you can't take that and split it up unless it's possible to factor whatever you have inside here. X squared plus y squared does not factor. But if you had log base 2 of x squared minus y squared, then you could say, aha, well, that can factor. That can factor, being a difference of squares, we can factor it as x plus y times x minus y, like that. And once you've written it as a product through factoring, then you can split it up like this. Log base 2 of x plus y plus log base 2 of x minus y. All right, that splitting up you can do. But then each of these individual ones, the log of x plus y and the log of x minus y, those cannot be split up further. Okay, so there's a certain amount of, it's a certain amount of familiarity you want to build with these properties so that you know what type of manipulations are allowed and which are not allowed. I mean, same with any other application of like algebra properties, right? Like distributive law. You just got to kind of familiarize yourself with what is possible and what is not. And if you ever are not sure, you're always welcome to ask. Or just stick in some numbers and see if you get the same value on both sides. And if you don't, then it was not valid. That's always a good test. 14.